everybody, Harold here. Today I want to talk to you about an R package called VisDat. When I get a data frame, data set, I like to get a first glance at it, kind of an overview. And a lot of times the packages you see will give you something like this, just a bunch of numbers. It's great stuff, number missing, number count, stink count, mean, so on and so forth. But I like to get also, or even better, a good visual view of my data and the quality of it. And VisDat is great for that. So now I can get something like this. So here is VisDat of a data frame called typical data, and it shows you missingness and data types by color. Really great first glance at what you've got here. You can see there's a lot of missingness in 4 of these columns. You can tell where your data types are, what your data types are, and observation counts, just a general glance. So let me show you over in R how we use the VisDat. So uh, in R, blow this up a little. You're going to need the following packages: tidyverse, VisDat, skimr, and car data. Uh, you don't know, you can install packages, put them in quotes in parentheses to install them, and then just in parentheses to load them with the word require or library. Library and require are equivalent. So once you've got that done, you may take a second and pause. Go ahead and run all these. Tidyverse, VisDat, skimr, and car data. In car data, there's a database called MPLS stops. Before I show you VisDat, I want to run through the traditional methods of getting a summary view of our data. And a lot of people, first thing they do is say head, which gives you the first few rows of the database. But that's all you get. You might think, hey, there's a problem with NA in the citation issued column, but or pre-race unknown, but those could be the only of those values in there, and you're just seeing 6 of them. So it's not much, just a good look at it. A little more you get with structure, str, MPLS stops. That's going to give you the column name, how many observations of variables, tell you the data type of the column, and give you the first few observations. So that's good stuff. It's still just a lot of numbers, not visually appealing. I'm going to start piping things in. If you're not familiar, this is the pipe. Everything after the pipe gets the arguments before it, so MPLS stops will be considered the data for everything below it. That's from the tidyverse. So MPLS stops glimpse. Glimpse gives you, again, columns and rows and data type and first few observations. Uh, Another one is summary. Summary starts getting a little more detailed. It'll give you counts of variables, some statistical information, min, median, mean, quartiles, and max. Uh, and so you get a lot more out of summary than you did out of the first ones, but still, you can search around here and find how many NAs there are. Still, I'm looking for something visual. And one more I want to show you. It's pretty good. It's from the skimmer package. It's called Skim, and I'm just going to skim Iris because MPLS stops is a little big for this. So, what Skimmer does is gives you a summary of rows, columns, uh, type frequency of the columns, group variables, what they are, how many are missing, what the values are, and then on your numeric types, it gives you the mean, median, missing, complete, and a nice little histogram. So you are getting a little visual here, but not quite what I'm looking for still. This is all great for analysis stuff still. So let's go look at VisDat, and I'm going to give you a glimpse of the typical data so you see what we're working with. So there's a glimpse of typical data. It's just some made up data with all kinds of data types they use for demonstration purposes. Boolean, numeric, int, double, factor. Well, in this one, they're just character, factor, double, and logical. So you want to VisDat, show your types and missingness. There we go. Our VisDat with the colors for the different data types all lined up, ready for us to check out our missingness. They're sorted by data type, and then sorted by data type. So you get a good view of your data, what type it is, and the missingness. Uh, if you want to look more into the missingness, you could say vis underscore miss typical data. That gives you this great plot showing each column and the number of missing values, percentage of missing values, and overall total percentages of missing and present values for the data frame. So now you're cooking. You got a lot more insight into your missing values. You wanted to keep that the way your data frame is sorted. It's sorted by factor. You can throw in the argument sort type equals false. And back on the VisDat, your sort type will now be original order. No argument will default or true. Will take you to ordered by data type. If I say sort miss equals true, that clusters all the columns with missingness at the left to the front, so you can kind of pick them out easier. If you want to get even, you want to cluster them, you do this. That clusters all the missing values in the column, and the clusters kind of gives you a chunk of the data clustered that's missing. So we've done viz miss and viz dat. The next one is viz compare, and that compares two data frames of the same dimension. So I can't have a 2x3 and a 3x2, but if I have a 3x3 and a 3x3, I can use viz compare. So if you had a monthly table and it was changing, you want to see where it changed, you could compare month to month as long as the table structure remained the same. And I'm going to use the built-in dataset orange for this. So you'll see orange, it's just a list of trees, their age and their circumference. Uh, what I did here was orange 2 is equal to orange. I assigned this to orange 2. I made orange. I took the circumference. Anything that was greater than 100, I just added 1 to it. If not, I left the old circumference. So there should be changes for any tree whose circumference went over 100 when I compare orange to orange 2. So let you look at orange 2. So that's just, there's 177 on tree 35 and 178 on 35. So it's slightly different. Let's VisDat our orange. Okay, it's just 3 columns, 2 numeric and 1 ordered factor. Now, all right, let's do the viz compare. So I think this is really cool. It shows you how much your circumference changed and where it changed. So the the skinnier trees where they didn't change are down here in the orange, and then all the changes are in gray. I really like that. Uh, so the next thing you can do is there is a function called viscore. It lets you visualize the correlations in your data. So let's stay with orange here for a second, and we'll viscore orange. Well, I got an error. When you do a viz core or viz values, you've got to remove everything but numeric data types or it will not work. Uh, just to give you some R practice, I thought we'd create a function for this. So I've said numbers only is a function that takes a data frame as an argument. And what it does is takes that data frame and then selects only the columns that are numeric. So we'll use that function and then we'll say orange numbers only viz core. And there you go. So dark brown is high correlation. They're of course correlated 1 to 1, 1 which is the highest with themselves age to age, but there is also a huge high correlation darker brown between circumference and age. So really quick, that gives you a great visual. Really quick, that gives you a great preliminary analysis of where the correlations and not correlations might be in your data. Show you even further. Let me show you that in the layman batting database, give you a better overall visual, a larger database. So here's a lot of variables. You can see it's always going to be 1 to 1, 1 on this diagonal, but uh, doubles are correlated highly with at bats, of course, but you can see the lighter, your ID, of course, is not really correlated with much at all. And so you could pick out the darker ones for higher and the lighter ones for lower correlations just at a glance. Really like that one. Uh, so I'm going to add, since I'm using this so much, I made another function called numbers only core and just added a line with viz core. So let's use that one. Uh, numbers only core for MT cars. Another one, good example of where MPG and weight have no correlation, but there's a higher correlation for displacement in cylinders. So there you go, viz core. Um, I said there's one called values. Viz values is visualize values on a 0 to 1 scale. And so let's say orange and drop our numbers only because you could only use numerics with this value. And we'll run that. So what that has done is shows you how the values change. So the tree gets higher, the circumference gets bigger, kind of on a log scale of 0 to 1. Kind of a nice way to see how your data changes over time or whatever variable you choose. So next one is binary. That lets you visualize your distribution of Boolean values. They put a nice database in here called DatBin, included with VisDat that'll show that. So that's all Boolean. It's either 0 or 1 or NA. So you can see your distribution of Booleans. This binary. Now, the next one is visualize values that meet a condition. So here you give it the variable and the condition tilde.x greater than equal to 100. So we want to see orange trees where we expect that value to be greater than 1, where the value is greater than 100 in circumference. And there we go. It's true in the orange and false in the gray. So as the tree got fatter, wider around, it went from gray to orange, false to true. And the last one to do is viz guess, which kind of tries to guess what your column types, data types are in the columns, give you a feel of what it was before They convert based on the majority. So I'll show you. This guess gave me, we pretty much knew what they all were except for this ID column. It saw the first so many as a character, and then after that, it saw them as a number, and I could probably guess what that is. ID is probably, and I think we might have seen it before, 0001, which is a character. And then when it gets to 1,000, it starts thinking they're numbers. Because 0999 is a character, and then 1,000 would be a number. But let's look at it, see if I'm right. And yes, if we go up to it, let's just view typical data and see if that's the case. Sure. And we'll sort ID the other way. And yeah, so when it got to 1,000, it started seeing these numbers. So this is what it thought when it first saw our data, and it was, and based on this, because it had characters in it, it had to turn it into characters. So when you go back to VisDat and VisDat, your typical data, ID all came out as character because it can't tell. And it thought some were characters, so it can't make a number a character, so it made them all character. Okay, so that's VisDat. I hope you liked it. Hope you get something out of it. Hope you use it next time you bring in a new data set. And if you did like this, please like it, subscribe, and I'll see you next time. Thanks, everybody.